Okay, this is year 10 maths. We are still in unit 5, and this is called then lines that do not pass through the origin. A better name for this wee video would really be y equals mx plus c lines, because we're looking at this formula on how it relates into these kind of straight line graphs then as we see them. So it says when given a graph that does not go through the origin, we have to work out the gradient in the same way as before, and the y-intercept. So the y-intercept is the y coordinate whenever x equals 0. It's a fancy way of saying it's where the graph crosses the y-axis, and this of course here then is always our y-axis. So in this particular case the y-intercept would be, that's a 2 and that's a 4, and it's halfway in between, so it's going to be a 3. So the y-intercept here would be 3. Use the following graph to find the gradient of the line. Write down the value of where the line crosses the y-axis. Make a table showing the x and y coordinates of 4 points and find the equation of the line. We're going to go a couple of different ways about doing this, but let's see if we can find first of all then the gradient of the line. So we pick a few points on it. This is kind of funny looking here. It's kind of hard to see, but that's actually a point on the line. That's the point 27. I hope we can see that okay. It's just because it's kind of wee, it looks like it's kind of half squares and stuff, but it's not really. And there's another point. Again, I've just found the one that looks like it's going through, and that's the point -2, -1. So how do we find our gradient? It's the difference in the y coordinates, so that'll be 7 minus -1. And then the difference in the x coordinates, it's 2 minus -2. So that'll be 4, so our gradient then is 2. It's just quite awkward to see, but what they're saying is here the gradient's 2, the steepness of the line is 2. Every time you go across one, you're going up 2. So if we go across one here, you'll realise then it's gone from, that's -1 on the y-axis to 1. So sure enough, you go across one, up 2. It's just the scale's a wee bit funny here for this one. Y-intercept then, as we know, is going to be 3. And so then that's our y-intercept. We could draw out a wee table of values showing 4 points on the line. Let's see if we really need to do that. Yeah, go on. Let's do it. There's 4 points there, so we can just write those in. Just seeing it as asked us to, but I don't think it particularly helps with working out our equation of the line. So x value on our y value. So what's this point here? That is -2, -1. That's the point 0, 3. That's the point 1, 5. And then that's the point 2, 7. But our most important bit to realize from this is that if you can find the gradient and if you can find the y-intercept, we can substitute it in and find our equation of the line, because our line is of the form y equals mx plus c, where this is the gradient, so in this case it's 2, and the y-intercept then is 3, and that's the c part, and so our equation of the line is y equals 2x plus 3. This is particularly useful going backwards, and in fact one of the exercises you're about to do is to draw these. So if we know this, we can start with the point 3 on the y-axis and then go across 1 up 2, across 1 up 2, and to help us draw that. Let's take a look at the next wee example and see if we can just kind of draw it on here. I'm going to do it actually without using the table. So this one says draw a graph of 3x plus 3. Use the values of -4, -1, 3 and use it to find y when x is -3 and 2. I'm going to cheat here a wee bit, but it's the graph y equals 3x plus 3. This 3 tells me that it crosses the y-axis at 3, so I know that this is a point on the line. This 3 tells me the steepness of the line, so you can't see that. The steepness of the line here is 3, so that means every time I go across one, I go up 3. So let's see if we can do that and actually draw the line. Across 1, up 3, across 1, up 3. It's not going to fill in there, so I'm going to go backwards. Hope you can see it kind of goes in like this. That's 1, down 3, and so on. And that's our line, then we can draw it on. So get it nice and accurate if we can. And the name of that line is y equals 3x plus 3. Not the best example because they are both 3, but this 3 here represents the y-intercept, so it crosses at 3. This 3 here represents a gradient. Every time I go across one, I'd be going up 3. Let's just check our values here to make sure everything suits okay. So they wanted us to use -4, -1, and 3, and we're substituting it in into this formula here. So let's make sure it does actually fit. 3 times -4 is -12, plus 3 is -9. -1 in instead of x, and 3 times -1 is -3 plus 3 is 0. And then 3 times 3 is 9, plus 3 then is 12. I don't think that one's going to fit in, but that's okay. So let's check the point -4 -9 is on. -4, can't see this, need to move it up a bit. So there's -4 and then down to -9. Sure enough, that's one of the points in that I plotted. -1, 0, -1, 0 is on it. And then 3, 12 would be on it if it fitted. 3 across and then up to 12, and then we'll see from there. Okay, I'm going to run through just one more example here. I know it's not part of our notes, but just think it might be useful for people. So say we had y equals -2x plus 4, and I wanted to draw that one on. What I would do would be the following. I take this 4 because I know that's the y-intercept, so I know this line crosses the y-axis at 4. And a gradient of 2 means every time I go across one to the right, I go up -2. That's a silly way of saying that, obviously. That's the same as going down 2. So across 1, down 2, across 1, down 2, across 1, down 2, and you soon get the idea of the shape of the line. If we're drawing these lines, they should go all the way through the grid that we have drawn on here. And so sure enough then, I'll just do it lightly because it's not really supposed to be here, but it's just to give you a bit of an idea of what's going on. And the name of that line then is y equals -2x plus 4. Of course, you can still go back and do your table of values that you've been doing for the last couple of examples. You could draw a table of values, pick some numbers for x, for example -2, 0 and 2, substitute them in and draw it. But this is a much more efficient way of doing it if you know that this is the y-intercept and that this is the gradient.